So here is question number 36 everyone. In the given resonating circuit, the reading of voltmeter V is 314 volt. The value of inductance L and resistance R respectively will be what? Now, resonance condition is already mentioned here in the question. It means VL must be equal to VC and VR will be the total value of V only, because VL and VC, they will cancel each other. Now from here we can say IXL, that is VL, 314, equation number 1. IXC, that is VC, same 314, equation number 2. And IR, that is VR, that is V, 220, equation number 3. Now taking the ratio of 2:1, that is XC by R, we have got 314 divided by 220, or we can write XC, that is 1 upon omega C. So 1 upon omega CR, that is 314 upon 220. We can get the value of R from here. R equals 220 divided by omega, that is 2 pi into frequency 50 multiplied by capacitance 10 into 10 to the power minus 6 multiplied by 314. And after solving this particular value, we will get the value of R simply as 220 ohm. So this is the value of resistance we have got. Now from 1 and 2, 3, from 1, 2 and 3, let's take the ratio of XL and R. XL by R, that is 314 divided by 220. XL, that is omega, equals 314 multiplied by R, that is 220 divided by 220. 220, 220 cancel out. Omega or L equals 314 divided by omega, that is 2 pi into 50. This 2 pi 50 will be cancelled out with this 314, and you will get the value of L as 1 Henry. So inductance 1 Henry, resistance 220 ohm. We have to go with option number 1, which is absolutely correct. Now move on to the next question. Here is question number 37. The RMS value of electric field of a light at a point coming from the sun is 800 Newton per Coulomb. The average total energy density of light at that point will be what? We know very well the average total energy density, U average total, is given by epsilon naught E square, where E is RMS value of field. Putting the values, 8.85 into 10 to the power minus 12 multiplied by 800 square, and after solving we will get the value as 5.67 into 10 to the power minus 6 joule per meter cube. So therefore we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now move on to the next, that is 38 number. So here is question number 38 everyone. A parallel beam of light consisting of red and blue color is incident on a prism as shown in figure. The refractive indices of prism for red color is 1.4 and for blue is 1.47. The prism will, you are having 4 options that which ray will come out or which ray will not, given that sine 44 equals 1 by 1.44. Now which ray will come out, which ray will not, it depends upon whether the light ray is suffering from refraction or total internal reflection. So we have to check TIR or simple refraction. First of all, angle of incidence for both rays will be what? 90 minus of 46, that is 44. Now let's check for the red color. For red color, let us calculate angle of critical or critical angle for red color. IC for red will be what? Sine inverse 1 by mu for red, that is 1.40. Or we can write sine IC for red equals 1 by 1.40. Now, since sine 44 equals 1.44 and sine 1.40 will be, now we can compare it with sine 44. How? See, since 1 upon 1.40 is greater than 1 upon 1.44, it means 1 upon 1.40, that is sine IC. So sine IC will be greater than 1 upon 1.44, that is sine 44. So here we got the critical angle IC, that is more than 44 degree. Angle of incidence is 44 and critical angle is more than 44. It means, therefore, here I is less than IC, therefore no total internal reflection occurs, so red will come out through BC. Now we have decided for red. Now let us check for the same for blue color. For blue, sine IC for blue will be given by 1 by 1.47, refractive index of blue. Now 1 upon 1.47 is smaller than 1 upon 1.44. Very much clear. Now 1 upon 1.44, that is sine 44, and 1 upon 1.47, that is sine IC. So from here it is clear that IC is less than 44 for blue color. So for blue color, IC is less than 44. On the other hand, angle of incidence for blue equals 44, or you can say I is more than IC. Therefore, blue will suffer TIR, and it is suffering from TIR, then it will be reflected. It will not cross BC. So we can say that red color comes out of the BC, but blue color will not. So finally we can say red will appear through BC. On the other hand, blue will be reflected. Now let us check the options. Separate both colors and both emerges from surface BC. Wrong. Separate both colors and only blue light emerges from surface BC, which is also wrong, because red is emerging out. Separate both colors and both are reflected back. Wrong. Fourth option, separate both colors and red color light emerges from surface BC. Absolutely correct. So we'll go with option number 4. Now move on to the next, that is 39 number. So here is question number 39, students. The interference pattern is obtained with two coherent light sources of amplitude ratio n. In the interference pattern, the ratio Imax plus Imean upon Imax minus Imean will be what? Given that A1 by A2 is what? N. You must be knowing that maximum intensity Imax will be what? A1 plus A2 whole square. On the other hand, minimum intensity Imean will be A1 minus A2 whole square. Now let us putting the value of Imax and Imean in this expression and see what we are going to get. Expression will become A1 plus A2 whole square plus A1 minus A2 whole square, whole divided by A1 plus A2 whole square minus of A1 minus A2 whole square. Further solving it, we will get 2A1 square plus 2A2 square whole divided by 4 times A1 A2. Now 2 will be cancelled out and we will get A1 square plus A2 square whole divided by 2A1 A2. A2. Now let us dividing by A2 square on both numerator and denominator. Dividing by A2 square both numerator and denominator, we get A1 square upon A2 square plus 1 upon 2 times A1 by A2. Now we must be knowing that A1 upon A2 is n, so therefore expression will now become n square plus 1 upon 2 times n. So this is the final expression which we have to calculate, n square plus 1 upon 2n. So we can say that we have to go with option number 2 only, which is absolutely correct. Now move on to the next, that is question number 40. So here is question number 40, everyone. Photoelectric threshold wavelength of metal is 300 nanometer. The maximum kinetic energy of electrons ejected from the metal surface by UV light of wavelength 250 nanometer is nearly what? H we have to take in electron volt second and C in meter per second. Now we are knowing, according to Einstein photoelectric effect equation, Ke max, maximum kinetic energy, is what? Hc by lambda minus Hc by lambda naught, where lambda is incident wavelength and lambda naught is threshold wavelength. Everything is given in the question, so let us plug the values from the question into this expression and calculate the result. We will get H 4.14 into 10 to the power minus 15 multiplied by C 3 into 10 to the power 8 divided by lambda, that is 250 into 10 to the power minus 9 minus Hc again, so 4.14 into 10 to the power minus 15 multiplied by 3 into 10 to the power plus 8 whole divided by, it is 300 nanometer actually, threshold wavelength, so 300 into 10 to the power minus 9. And after solving, we will get this value as Ke max equals 4.968 minus 4.14 and finally 0.828 electron volt will be the maximum kinetic energy of emitted electron. So we can say that we have to go with option number 1 only, which is absolutely correct.